Okay, hello everybody. So here are the solutions to quiz number 2. Number 1, 2, and 3, you're solving for x. So you're always telling me what x equals. And the key thing here to remember is that f of x equals y. So for number 1, this is -2 times y plus 1 equals 9, which is the same thing as saying that y has to equal -4. So for number 1, I'm looking for x values that produce the y value of -4. And I could see there are 2 of them. Once when x equals -3, then the y value is -4. And again, when x equals 0, the y value is -4. So that is the answer to number 1. On number 2, the absolute value of y is 1. So the distance that y is from 0 is 1. That means y could be +1 or y could be -1, because 1 and -1 are both 1 away from 0. Well, this y value is 1 away from 0, so is this y value, so is that y value. All these y values are exactly 1 away from 0. Now, what are the x values that produce all 9 of those y values? They are -6, -5, -4, -2, -1, 0. You get it. On number 3, what are the x values that produce the y values on f that are less than the y values on g? Well, f is the dashed. So these y values are certainly less than the corresponding y values on the other one. So all these y values, these are all ordered pairs, right? So all the x values that produce these y values are less than the y values on the absolute value function. So we are looking at those two sets. So x equals everything from -infinity to -0.541. That's this x value. So again, just to slow down, all the x values in this set will produce y values on the parabola that are less than the y values on the absolute value. And then union that with this other portion, everything from 4.193 to infinity. The next section is about operations and their domains. So this is g minus f, which is g of x minus f of x. So there's g, there's f. So x minus 4 is the answer. G minus f is the same thing as x minus 4. The domain, well, look, the domain is all the x values that can go into g and go into f, because both g and f are being used. G is a line that has all real numbers, and so is f. So the domain is just all real numbers. This is f times g. So f is -2x plus 6 times g. And again, this has all real as its domain, that has all real as its domain. So when you combine them together, the domain again will be all real. We simplify here a little bit, you get 2x squared minus 10x plus 12 as your final answer. G divided by f. Okay, again, you're using two different functions. F has a domain from -0.5 to infinity. G has a domain of all real. So when I combine them, I have to combine both of these sets. All right, g divided by f. Well, g is x squared minus 4. F is this. So the domain would be everything from -1/2 to infinity. But x can't be -1/2, because if x is -1/2, then you're dividing by 0. So this has to change to that. This next one is a composition. So this is g of f of x. Okay. So x is going into f first. X is going into F first. And that means that only X values from -1/2 to infinity are allowed because F can only receive numbers from -1/2 to infinity. Now, the square root of 2x plus 1, which is F, is now going into G. What does G do? G takes the input, squares it, and then subtracts 4. That's all it does. So G will take the input, square it, and then subtract 4. Well, the input in this case happens to be the square root of 2x plus 1. The square root and the square cancel each other out. So you get 2x minus 3. This is the final answer. That is G of F of X. Now the domain, well, look back to the beginning. The domain at this stage right here got shrunk down to -1/2 to infinity, and it remains there. There was no other operation. I didn't divide anything new. I didn't take the square root of anything new. So the domain remains -1/2 to infinity. So this is really deep, I think, and interesting. This is just a line, with a slope of 2 and a y-intercept of -3. But if you were to graph this, it would only exist beginning at x equals -1/2, and then it would just go to the right to infinity. Number 7 is again another composition. So this is f of g, but now the input is one specific domain element, 4. So 4 goes into G first. 5 times 4 minus 4, which is 20 minus 4, which is 16. The square root of 16 is 4. And now 4 goes into F, and that's 2 times 4 minus 3. So the whole thing is 5. Number 8 is obnoxious. G of F of G of F of 4. So looking at my graph, here's when X is 4, and F of 4 equals 4. So F of 4. Now I want to find G of 4. What does G of 4 equal? So I go to 4 and I find out G of 4 equals -2. So this is G of F of -2. Now back to F. Now -2 is going into F. Here's -2. F is the parabola, so it is right here. F of -2 equals -2. So this becomes G of -2, and G of -2 equals 1. A lot of work just to get to 1. Using the graph again, I've got letter B, which is asking, what is G of 2 minus F of 2? Well, G of 2 is, here's 2, G of 2 is -1. F of 2 is -2. So -1 minus -2 is again equal to 1. All right, so this one, G of F of G of X equals 1. You see how this is basically saying G of something equals 1. So G of what equals 1. So I go to my map and I see here's G, and it equals 1 for only one X value, when X is -2. So this must have been -2, which means this must have been -2. So I get to rewrite that. I can say F of G of X must have been -2. Well, again, you have F is receiving this. So F of something has to equal -2. So I go to my map. Here's F, which is the parabola. And when does f equal -2? Unfortunately, f equals -2 two different times. So it could be +2 or -2. Both +2 and -2 produce a y value of -2 when you're on f. So this right here, g of x has to be either 2 or -2. And so here is our final level. G of x has to be 2, or what's also acceptable, g of x could be -2. So I look at my map again. Here's when the y value is -2. Here is g. And when does g equal -2? Only once, when x is 4. So in this case, x could be 4. That is an answer because you were looking for x. This is asking for when g equals +2, and g equals +2 right there, when x is -4. So this one actually had 2 answers. I like that problem, but I don't like it for the test because it's a fun problem to do, but it's sometimes a little time consuming, and I don't know. Odd and even, guaranteed to be on the test. Only one way to show it. You have to plug in the opposite of x and then observe what you get. In this case, you have to show your work. It's all about showing your work. That happens to be exactly f of x. So by plugging in the opposite x value, you get the same y value that only happens to even functions. So quickly, for an example, f of 5 is 57. Since I know that this is even, without even touching my calculator, I guarantee that f of -5 is also 57. Replacing the x value with its opposite will give you the same result. For 11, you get to replace all the x's with their opposites. So 3 plus the square root of the opposite of x squared plus 9. Okay, we got some work to do here. This is 3 plus, well, the opposite of x squared is just x squared. And then in the denominator, you have -2x. Well, this is the same thing. This fraction is the same thing as this fraction, just by taking the negative out of the denominator and putting it up front. And what does that look like? That looks exactly like negative g of x. So what happened? You replaced x with its opposite, and you ended up with the opposite of the y value. That only happens with odd functions. So that function is odd. Sketch a graph that is odd. Anything you graph up here has to be graphed down there, or vice versa. Anything you graph up here has to be graphed over there. Odd functions are symmetrical through the ordered pair, or sorry, through the origin. So y equals x, that is odd. Y equals x cubed, that is odd. This is not odd because it is not reflective through the origin. You can do a couple, I don't know. Draw anything such that it's reflective through the origin, then it is odd.